I'm going to go over some thoughts or theory, I guess, about forge welding and a little bit of how to do that. And I'm going to be using, it's part of a bigger presentation for a basket handle project, which has several forge welds in it. And in this presentation, I'm using some photos and diagrams from Mark Asprey's books. So big thank you to Mark for letting me use those. And all of these can be found on the calsmith.org website or our YouTube channel. So with that, let me get started. I've got about 20 minutes worth here for you, so I'll try to get through this. So forge welding, our main tool is a hammer. So to discuss forge welding, I want to use the 4 factors that impact your metal with the hammer. So hammer penetration is our main tool, and that's what we're going to use to talk about the impact that has on your weld. And the first factor in hammer penetration is the type of metal. And for this demonstration or this talk, I'm mostly talking about mild steel, but you would need to know what type of metal you're using because different metal acts a little different. If you have a higher carbon steel or a tool steel, that's going to be a little harder for your hammer to penetrate. The mild steel is a lot squishier. The second factor in hammer penetration is how hot did you get your metal? And when you're forge welding can happen in a range, but it's the upper heated range. It's not where you're burning it and you see sparks. That's too hot and you're just losing material. But it is in the yellow hot or bright orange range. And it should look wet, like the metal's a little bit runny and ready to meet a new neighbor. If it starts looking crusty, meaning the scale has started to form, it's not ready to weld. So what does that look like? Here's a picture of, this is a drop tong weld, and you can see that here's the bottom piece, here's the top piece, and they're both the same color. They're both that yellow color. This is going to weld well. As the heat decreases out here at the ends, you can see that scale starting to form. When that scale forms on your piece, it's dirty and it will not weld. So it needs to be in this, it looks wet and you can see the flux running around and a little drippy. That will weld. Once you lose that temperature, it's no longer going to weld. And that becomes the key tenet to forge welding. You've got to get these pieces together in time to weld them while you still have clean welding temperature. Now here are 2 pieces that are different colors, but you can see they're both in the welding range. This is that bright orange. It's got that white look, a wet look to it. This is that bright yellow. That's clearly welding temperature, but they're not the same color. This initially stuck, but then fell apart. So this is not good welding temperature. Both pieces must be the same color, meaning they're the same temperature. So back to our hammer penetration factors. The third factor is the strength of the blow. And some people think that when you're forge welding, it needs to be this Hail Mary, I'm going to give it everything I've got kind of hammer blow. And it's really not. The weld is taking place on the atomic level. And you want to make that a gentler introduction by tapping the 2 pieces together and convincing them it would be a good thing to stay together. If you give it a really strong blow, you risk just kind of blowing that apart or deforming what you've carefully prepared on the end, which is what I'm going to talk about in a minute. And it'll just deform your metal and you'll be starting over. So you really want a light to moderate blow. The final factor in hammer penetration is the location of the blow. And I'm going to use the location of the blow discussion to do kind of a deep dive onto how we get the pieces together and where you hit them and why we make a scarf. The first weld I'm going to talk about is a faggot weld. And all that means is that I've put together a couple pieces of metal, a bundle of pieces of metal, and I don't have to arrange them on the anvil. They're going to come out of the fire, heated, and they'll be all together when they meet the anvil. So less time is wasted. This little diagram is showing you two sticks put together, and the weld is taking place in the middle. Our hammer blows need to come from this direction, and that might seem obvious, but it's going to be important that we define the welding plane and the hammer blows. And you'll notice they need to be perpendicular or 90 degrees-ish from your welding plane. If you hit them from this direction, they're just going to blow apart. They're not going to weld. So that's a shearing plane. So once you have once you're ready to go, you know where you're going to hit it and how hard and all that. It's just a matter of getting it hot, fluxing it. And it's important that you do it in that order. The flux is a time saver. It buys you a little time to get your pieces together and welded before that scale forms. The flux makes a little glassy surface and it can be a little corrosive, so it can dissolve some of the scale and prevent some of the scale just for a couple seconds, which might be all you need to get it out of the fire onto your anvil and be hitting it. But if you apply that flux to a cold piece of metal, like even if it's 800 degrees, it's just going to form this big crusty glob. You want your metal heated to welding temperature. Apply the flux so that it just kind of runs into all the little crevices. And then, since you're going to have lost heat with that little exercise, reheat it, position it, hit it while it's yellow hot. And here's that happening. Here's the weld, and the hammer blows come from here. Once you've started your initial weld, you're going to turn it over, do it on the other side, as long as you still have welding heat. If you don't have welding heat, right back in the fire. So it's heat, flux, reheat, hit, repeat. And my rule of thumb is I want to weld at least 3 times before I'm feeling really good about that weld, and then can move on to forging it. So next I want to get into the drop tongue weld. And our major issue with having 2 separate pieces that we're bringing together is we have to align them where we want them to weld and hold them there and hit them before we've lost our welding temperature. So it's a bit of juggling, like it's a bit of maneuvering, and that's something you need to feel confident about. And by confident, I mean you've practiced it. If you've practiced it cold, not hot, you'll know what you're going to do. And, you know, there's a lot of, oh, maybe the birds have to be singing the right tune to get a good forge weld, but practice, practice, practice is what's going to get you a good forge weld. So we won't have to worry what tune the birds are singing. So what does a drop tongue look like? Here is, and you can tell this is Mark, not me, plus I'm left-handed, but here's a picture of Mark executing a drop tongue weld. And there's a lot going on in this picture. The first is we've got a right-handed smith, and I can tell that by a couple things. The first is I've got the hammer all ready to go. The hammer is on a clean anvil. All the scale and anything that happened while making or preparing these pieces has been brushed off. So hammer's ready to go. The tongs are holding the smaller piece in the hammer hand. That hammer hand comes all the way around the far side of the anvil. You set your piece, like anchor it on the side. This piece is also going to be anchored on the side. And The tong piece goes on the bottom. The longer piece held in the material hand goes on top. You drop the tongs. Here's the tongs. Mine usually end up out here on the floor somewhere. Pick up your hammer and you hit. And I like to do that to a nice slow count to 3. 1, I've recognized my pieces are hot and ready to go. I have them positioned in the fire the way I want to bring them out. 2, I'm over at the anvil. I'm anchoring them on the sides, positioning them. 3, I've dropped my tongs, I've picked up my hammer, and I've hit it. That's the juggling. So that's what you should practice cold when you're ready to do this. So let's talk about these ends. These scarves on the end look like this up close and personal. And you've got a toe, which is a 3-sided taper, a heel, and then a neck. I don't know why we switched from a foot theme to a neck, but these are the terms I'll be referring to as I talk about a scarf and why we want a scarf. So here's essentially what we're doing. We're taking 2 pieces of metal, we're putting one over the other, and we're welding them together right along here, the welding plane. My hammer blows come perpendicular-ish to that, but there's something amiss here with this edge. This is not in a welding plane. This is in a shearing plane, and to me, it even looks like the sharp edge of a chisel. And I've done this with 2 pieces of metal, and I highly suggest you experiment as well. Try putting one piece down into another piece, and you will end up with these cracks. It literally shears that, forms a chisel point, and that's no good. You're not going to ever be able to uncrack those cracks. The easy way to get ahead of that and outsmart your metal is to put that edge in the welding plane. And that's why I always say 90 degrees-ish. It has to be roughly 90 degrees to your hammer blows. Now, when I hit this, I am going to angle my hammer so that I follow this toe down to blend that in. But you'll notice this is all now in this welding plane. It's no longer in a shear plane or a chisel plane, and that weld will come out very nice. But there's another factor that takes place when you're hitting one piece of metal on the other, and that is the top one is going to move a lot faster width-wise than the bottom piece. You could even say that this bottom piece becomes an extension of your anvil. It's not going to move. It's not going to widen like that top piece. And wings are going to develop. And you're going to have to stick this weld 2 or 3 times before you can turn it on its side and hit it on what I would call, like hit it right here on the shearing plane. So that's going to grow and grow until you've got these little flaps hanging over the edge that now you don't know what to do with them. You're going to have a hard time blending them in. So bringing in the toe and making a 3-sided taper gives it room to grow while you're hitting it. Next is, how long do we want this weld to be? And a shorter weld is advantageous because since we have to have both pieces the same heat, it's easier to heat 2 pieces to the same color if it's a short weld. So stick a little shoulder in there. And the little shoulder will give you a thing to line them up to when you're juggling them and trying to line them up. And then finally, the neck is in a lot of trouble. It's in a vulnerable spot because we're going to hit here and then hit, excuse me, and then we're going to follow down that toe to blend it in. You're going to hit this once or twice and thin it. And if you want this all to be a nice even weld without thin spots, start with that a little thicker before you put your scarf in there. You're also going to lose some material to scale. So that's another good reason to have this a little thicker. This is already thicker. But having it a little bigger to start means you can end up with at least the same size as your parent stock when you're done welding. So thicken the neck, 3-sided taper, put a little shoulder in, and notice that the shoulder is round. That prevents another shearing plane from showing up in the middle of your weld. Then you're ready to execute your drop tong weld. Hammer's ready, anvil's clean, tongs are held in your hammer hand, anchor on the sides, put them into place. Once this top bar is holding this in place, you can pick up your hammer, hit it, follow that toe down, blend it in. You can already see that hammer hit here once or twice. And turn it over. If you still have welding heat, do the same on the other side, hit the top, blend that toe down. And after I've done that, both sides, at least 2 times, maybe 3, now I can start forging and getting it all to the width that I want. And in this, for this particular project, it's a nice taper from here to here. So that's your drop tong process. And it's the same as anytime you weld. You heat it, you apply your flux to welding temperature metal, you reheat it, and then you position them while you still have welding heat, and then you weld. So that is using a coal forge. You can do the same thing in a propane forge, but you might run into a little trouble with time. The propane forge isn't going to be as hot. You're going to have a lot more scale. So I'm going to give you 2 other options for welding, forge welding, that get you away from the juggling. The first is rivet the pieces together. So you don't need that index, you don't need that shoulder, because you're going to match them up ahead of time. So flat on the bottom, drill a hole. This is 1/2-inch stock with a 1/8 hole drilled in it. And now you're going to position the pieces together with a little piece of rivet material. Use a washer on the bottom so you have enough stick out to head over both sides. And then you can put it in the propane forge and weld it. I did that as a little experiment. So here's my propane rivet weld all ready to go. And I welded it, I cut it in half, and the weld goes from here to here. I didn't blend my toes in so I could kind of see them later. I do have these funny little incursions, but I would call that a solid weld. If I was using this for tongs or something else, this weld is gonna stick. The second option you could do in a propane forge would be to tack a little bit, tack the sides with if you have a MIG welder. And I did the same thing. The weld goes from here to here. You can see where I didn't blend in the toes so I could find them later. And I cut that in half, and wow, that really welded nicely. It did get a little skinny from scale loss, so beefing that up would be important. But the tack, the only thing I would caution against here is don't overdo it. I want to be able to apply flux to this, and I want that flux to seep in. And then when I'm welding, I want it all runny in there so that when I tap it to weld, I get that any scale or debris can ride the flux out. You see that little flash? That's the debris, the scale, and the flux riding the wave outside, out from where you want to weld. So that's the propane forge. And I have an induction forge, so I didn't do a whole lot with that other than I tacked a piece together and did the same little test. And I was a little worried about the induction forge not heating to the center so that my weld might be suspect in the middle, but I got a good result with that too. So since I was comparing the 3, I had 3 different types of scale on my anvil, and I collected them. And here's from the propane weld, here's from the coal forge weld, and here's from the induction weld. The coal and the induction scale was so skinny that it just kind of fell apart when I tried to get it on my piece of paper. The propane scale was thick and sturdy and left big chunks. So I just thought that would be interesting for everyone to see. I am ready for questions.
I have a question, which is, why would you want the flux to be between the two surfaces which are going to be welded? And why not have it, if they're close together, everywhere on the outside? Warum sollte zwischen den beiden Flächen, die verschmiedet werden, verschweißt werden, Flux sein, also Borax oder so, und nicht nur außen drumherum, wenn die schon so nah beieinander sind?
You can weld two pieces of metal together as long as those two surfaces are clean. So if you take two super clean pieces of metal and you put them under pressure over time, eventually they're going to weld together. We're trying to speed that process up, but we still need the two pieces of metal to be clean, which means no scale, no debris. So since our flux is our anti-oxidator, or it's preventing that iron oxide, or what I like to call high-speed rust, that's the two pieces where they meet is what I want clean. And that's what my flux is doing. It's preventing the scale from forming where the flux is applied. So that's why I want it on the inside.
Es ist so, dass die beiden Oberflächen, die verschweißt werden, sollen unbedingt sauber sein müssen, also von Zunder und allem befreit. Und wenn man zwei Stücke lange genug zusammenpresst bei einer Temperatur, die hoch genug ist, dann werden die irgendwann verschweißen. Aber wir wollen den Prozess ja ein wenig schneller stattfinden lassen. Und deswegen nehmen wir eben Flux, oder also in dem Fall meistens Borax, um das Ganze sauber zu halten, damit eben die Flächen sauber bleiben. The next question from Mariano. What are the advantages, disadvantages of using sand instead of Borax? And in German, was sind die Vorteile, Nachteile, wenn man Sand anstatt von, oder Quarzsand ist das dann meistens, anstatt von Borax benutzt?
So I have never used sand. That is something I would have to investigate. I mean, sand, they make glass out of sand. My guess would be that that's the properties that help sand work if people are using that. I've only ever used the Borax.
Die Antwort darauf ist, Victoria hat bisher nur Borax benutzt, also bisher nie Sand benutzt und kann deswegen dazu nicht so wirklich viel sagen. Und dazu gibt es mehrere Posts aus dem Chat. So there are some answers to this question in the chat, which are from Michael Post. Sand verklumpt das Feuer, mehr geht auch. So sand is bringing more, clinker to the fire. Job van der Zijden says sand stays longer on the steel. In German, Sand bleibt länger auf dem Stahl. And Rochelle said, I've used sand in coal. To me, there wasn't an advantage or disadvantage. It was dirtier and may have more inclusions. Rochelle hat Sand benutzt in einem Kohlefeuer und es gab keinen Vorteil oder Nachteil. Es war etwas schmutziger und könnte mehr Einschlüsse haben, aber hat gut funktioniert. But it worked well.
That's why I love doing these presentations. Somebody brings up a question and it's like, oh, now I'm going to go try that. So I'm going to go experiment with that.
Great.
And then I see another question in here. Can you weld wider than the hammer width?
Hello, Victoria. Can you weld wider than the hammer width? I find it always a problem that the weld is firmly in the middle, but at the end it's sometimes not welded. So in German, hallo Victoria, kann man weiter als die Breite der Hammerbahn verschweißen? Ich habe häufig das Problem, dass die Schweißung in der Mitte firm ist, also hält, aber zu den Enden hin manchmal nicht verschweißt ist.
So when you're, the short answer is yes, but you really have to blend in those edges. So if I'm welding two pieces together, I'm going to hit that middle, But then the rest of the time, like way more hammer blows are spent on the edges, the corners, and those, that light, I call it's like a blending, and light like a planishing blow. That is what's going to blend in those edges. So if you're doing something wider or longer than your hammer is wide, it's a matter of angling your hammer so that you get the fullering effect of a hammer and into those edges so that you're blending it. And I find that if I don't do that right away, there ends up with little flaps I really, really struggle to get in. And because then if I don't get that in right away, it's a matter of really brushing that, getting some flux in there, because it's just gonna get dirty. And now I've got a problem. I've got kind of a skinny piece of metal that's going to get hot right away. I've got a bigger piece of metal. I need them at the same temperature. So that blending initially while they're the same temperature becomes important. Otherwise, it's a matter of strategically heating the bigger piece so I can get that hot first and then maybe getting the smaller piece hot, same temperature, before I try to weld again.
In Kurzform, ja, man kann das natürlich machen. Man muss dabei aber darauf achten, dass man die Enden, die auch verschweißt werden sollen, entsprechend behandelt. Da über die Zeit der Schweißung, da sich mehr Hammerschläge konzentrieren als in der Mitte, muss man da eben besonders vorsichtig sein. Es ist auch wichtig, dass die Seiten zwischendurch eventuell nachgefluxt, also nachbehandelt werden mit Borax. Ich sage jetzt einfach mal Borax als Flux, weil man da eventuell wieder auf Temperatur kommen muss, um die Ränder auch vernünftig verschweißen zu können.
Well, and Mariano is bringing up a great point. You want to follow a pattern, and yeah, you want to, start in the middle and ease your way out to your edges wherever they are.
Mariano said, when welding Damast packages, one must follow a pattern. Blows are not to leave places without welding. Man muss eben auch, also besonders zum Beispiel, wenn man Damastpakete verschweißt, ein bestimmtes Muster befolgen, damit man nicht an einer Stelle keine Verschweißung hat. Also sprich, eine bestimmte Reihenfolge einhalten, um die Verschweißung eben konsistent über die komplette Länge zu haben. So, Rochelle has, make sure it's a good sand, fine with lots of silica. Es ist wichtig, dass der Sand fein ist und viel, ich glaube, das ist auf Deutsch Silizium enthält. Dann funktioniert das besser mit dem Schweißen. So then it works better with the welding. From Job van der Zijden, are different fluxes used in the heating sources you used? Wurden verschiedene Fluxe oder Flussmittel ist das auf Deutsch, Flussmittel benutzt in den unterschiedlichen Wärmequellen?
I did not. I used all the same fluxes in all of my three sources, mostly because it's what I had on hand, but then it seemed like a more fair experiment, if I'm going to test these all, keep some things consistent. I tend to use anhydrous borax, or just the regular, I don't know what you guys get there, but the 20 mule team borax, we can just get it at the grocery store. And then I have another kind of flux that has some little iron bits in it. So, and I'll judge my confidence for the day. Like if I try to weld it 2 times and for whatever reason that day's not sticking, then I go for the Iron Mountain and the little handy pour bottle, and that somehow mentally gets me to, this is gonna weld now because I have this other flux, and then it seems to work. At least that's what I did when I first started practicing drop tongue weld.
Nein, die sind alle mit dem gleichen Flussmittel behandelt, hauptsächlich, weil das Flussmittel war, was Victoria zur Verfügung hatte. Sie hat 2 unterschiedliche Fluxe. Einmal normales Standard-Borax, was man, soweit ich weiß, hier im Gartenhand, in der Gartensektion bekommt oder so. Zumindest teilweise in Belgien funktioniert das, hatte Philipp zwischendurch erzählt. Und dann hat sie noch ein Flux, ein Flussmittel Mountain Flux, irgendwie so heißt das, wo Eisenspäne mit drin sind. Und je nachdem, wie sicher sie sich an dem Tag fühlt, nimmt sie eines von beiden. Wenn es nicht so gut funktioniert, dann eher also dieses Mountain Flux, was eben auch in einer entsprechenden, ja, was ist das? Das ist keine Sprühflasche, einer entsprechenden Schüttflasche mit einer entsprechenden Öffnung, die das dann fein genau an die Stelle rieselt, wo man das haben möchte. I have a comment on that. Some of my friends here in Finland said they have been using the ground offs from lathe or file work or sawing, like hacksaw. We have tried this here, like with I have like a bandsaw, and it works like a charm. It works as well as the mountain flux, and here it's so much cheaper.
So here, this is the flux I'm talking about, and the part about it that's fun is this handy little pour spout. So rather than that's $30, I don't know what it would be in euros, but that's a great idea. Just add a little. So you're adding some of your shavings from some kind of fabricating into your regular flux.
Yes.
Yeah, maybe I'll add that to my bottle and see how that works.
Yep, yep. And there are similar bottles like for shampoo, like traveling shampoo package. Victoria hat gerade das Flux, also das Flussmittel, was sie alternativ benutzt, gezeigt. Und ich hatte noch den zusätzlichen Kommentar, dass hier ein Kollege in Finnland mich da drauf gebracht hat, man könnte doch auch Eisenspäne, ich habe die zum Beispiel vom Sägen, man könnte sie auch vom Feilen haben oder von der Arbeit mit der Drehbank einfach hinzufügt und anstelle dieser wunderbaren handlichen Flasche mit der Streuöffnung kann man auch relativ gut eine Shampooflasche benutzen. Die haben eine ähnliche Öffnung. There have been several more comments in the chat, which I have not read yet.
Well, I see one, does the amount of flux matter?
Ja. Ist die Menge des Flussmittels entscheidend?
The flux, I think of it as it's buying me a couple more seconds, buying me some time. If I put so much flux on, I've created a crust. Now I've defeated my whole purpose. If I put too little, it might not work enough, but I do find that less is more. So just a little bit, just enough where you see it melt and you get a little, you can almost see it like just start running around on there and it gets everything nice and wet. So if you take a little pinch, that's generally more than enough for your weld. So I would say too much could get in your way. And less is more. There's my end. So Patrick, if you want to make it simple, less.
Die kurze und knackige Übersetzung, weniger ist mehr. Eine kleine Prise ist meistens genug und wenn man zu viel benutzt, dann könnte das auch die Schweißung verhindern, weil das dann an der Stelle bleibt, ähnlich wie Zunder da auch die Schweißung verhindern oder ein Problem hervorrufen würde. There have been some more comments to the chat. Mariano Garabato, Tony Swayton tells me that you can use ammonium chloride for weld SRA 5160 steel. This counteracts the problems of chromium oxide, for example. Tony Swayton hat Mariano dazu gesagt, dass Ammoniumchlorat für die Verschweißung von einer bestimmten Stahlsorte, welche Chrom enthält, weil dieses bestimmte Ammoniumchlorat die Schwierigkeit mit dem Chromoxid behebt. Spring steel, thank you. Das ist eine Form von Federstahl. So the next question. Borax is not able to solve oxidization from previous forging processes. Is this correct? Do I have to descale it before forge welding every time? In German? Borax ist nicht dafür geeignet, das Oxid von vorherigen Schmiedeprozessen zu entfernen, also den Zunder vom vorherigen Schmiedeprozess zu entfernen. Ist das richtig? Muss ich jedes Mal entsundern, bevor ich eine Feuerverschweißung machen möchte? Victoria.
Oh, okay. So, if you heat it to the right temperature, some of that's going to take care of it on your own. But when you think about applying flux, you should give it a quick brush. Just get off any big debris. Debris is going to get in the way of your weld. You don't need to bring it down to a big shine or make it super, super clean. The heat and a quick brush ought to do that for you. The flux will dissolve some of it. If your piece got really wonky because of whatever process you're using, I would say, yeah, brush that a little more. But so for my experiment, I tried one where I got it really clean before I riveted it together and welded it. And then one, I didn't worry about it at all. I riveted them together and I welded them the same. I noticed no difference between the two. So if you're getting it to the right temperature, that iron oxide's going to kind of go away, and it'll ride that flux out if you've got it seeped into all the crevices. So no, descale lightly. How's that?
Ja, bis zu einem gewissen Grad nimmt das Borax den Zunder weg, aber auch nicht so viel. Aber es ist auch relativ egal. Es ist ausreichend, wenn man die Fläche zum Beispiel mit einer Bürste oder so, im Zweifelsfall auch mit einer nassen Bürste, habe ich in der Schule gelernt. So sometimes a wetted brush, like from the quenching bucket, can also assist in this. It seems to get a bit more powerful. I don't know for which reason. Yes. And das führt dazu, dass das sauber genug ist. Victoria hat auch ein paar Schweißversuche gemacht, wo sie vorher bei der Vernietung ganz sauber gemacht hat mit Schleifen und einmal sich überhaupt nicht darum gekümmert hat, und die Ergebnisse waren beide Male sehr gut. Also kurz gesagt, ein bisschen Bürsten reicht.
So, der Witz bei der Sache ist ja auch, dass man, weil du gehst ja mal locker auf deine 1200 bis 1300 Grad, und wenn du denn deine Flächen, die kannst du vorher so sauber geschliffen haben, wie du möchtest. Es gibt ja so Spezialisten, die sagen, wenn die sich da Mastpakete machen, die verschweißen denn jede Rohlage des Paketes rundrum, damit innen drin nichts oxidieren kann zum Beispiel. Aber letztendlich, wenn du auf deine Temperatur gegangen bist, hast du es doch automatisch schon oxidiert. Du kannst also diese Oxidation nicht verhindern, und da hat sie verständlich völlig recht. Es geht um die richtige Schweißung. Ich glaube, genauso wichtig ist das passende Material. Das ist, glaube ich, mit das Allerwichtigste. Ne?
It really doesn't matter, because anyway, if you get it to this temperature, and we all know what forge welding temperature is, so I don't mess with Celsius and Fahrenheit. If you get it to this temperature, it will oxidize anyway. You cannot do it. And he said there are some people, who make these dumbass packages. They do it really clean. They grind everything off and they weld it all the way around so it doesn't oxide. And he said it's all bogus because it will oxide at this temperature anyway.
No, Matt, that's absolutely right. That's going to happen. We're just buying time for welding to get it stuck together. You're buying time to get it stuck together before you see that crusty stuff form.
Victoria ist genau der gleichen Meinung. Es ist nur dazu da, dass einem das ein bisschen Zeit verschafft. Sowohl das Flux als auch das Säubern. So there have been several more additions and some very handy ones. So another suggestion from Rochelle was to use 1095 powder. So this is some kind of steel. With anhydrous borax and mustard or spice bottle to contain it. Rochelle vermischt Späne oder ähnliches von einer bestimmten Stahlsorte mit anhydrous borax als Flussmittel und benutzt eine Senf oder ähnliche Flasche oder eine Gewürzflasche, um das zu verteilen, ähnlich wie diese Mountain Flux Flasche. Becky said, I use old spice bottles too. Right now it's in an old garlic powder, so it smells nice. Becky benutzt auch alte Gewürzflaschen. Im Moment ist es in einer alten Knoblauchflasche. So, es riecht sehr gut. Michael Post said, man kann, wie du Patrick sagtest, historisches Eisen, because it's very easily weldable, so that's wrought iron for English speakers. Man kann, wie du Patrick sagst, historisches Eisen, weil gut schweißbar, feilen und die Späne auffangen. Das mit Borax vermischen, habe ich schon ausprobiert. One can use wrought iron, because it's very good weldable, file it off and mix this with borax. It works very well. He has already tried it. Another good tip from Robin Moot, another good idea is to use a sugar sifter, I believe, which helps sprinkling your borax in a very fine grained quality. Ein weiterer Tipp ist auch, dass man ein Zuckersieb oder ähnliches benutzt, dann wird das Borax etwas feiner verteilt. There is another question from Becky, which is, what's the best way to get the flux off the piece once you're done forging? Was ist die beste Möglichkeit, das Flussmittel hinterher, wenn man geschmiedet hat, wieder vom Werkstück zu entfernen?
I like to brush it while it's hot, and I find that gets most of that if you've got any crusty forming on there, because if you've applied a lot, you could end up with gunk on there and it'll kind of bubble up and leave a little mess. So just brush it while it's hot.
Victorias Vorschlag dazu ist, dass man das einfach heiß abbürstet oder warm abbürstet, sagt man ja auf Deutsch, weil dann das Zeug, der Zunder und Klinker und alles, was da so drauf ist an Boraxresten, dann sich einfacher entfernen lässt.
I want to add one more comment. There's a lot of conversation, or I'm going to call it like angst about flux. And I want to say something very clearly. You can weld without flux. Flux is just buying you time. And it seems to be a huge confidence boost. It makes you feel like, oh, I can do this. I have this magic powder. So keep in mind, you can weld without flux.
Victoria hat noch eine zusätzliche Anmerkung gemacht. Ganz wichtig, weil es viel Angst, das ist ganz witzig, das ist ähnlich, das ist das gleiche Wort im Deutschen, zu diesem ganzen Flussmittelthema gibt. Und zwar, man kann ohne Flussmittel Feuer verschweißen. Das ist vollkommen möglich. Aber Flussmittel sorgt dafür, dass man etwas mehr Zeit zur Verfügung hat. Und für manche Leute ist das auch ein Boost, eine Bekräftigung der eigenen Fähigkeiten. Und man fühlt sich dann einfach sicherer, weil man dieses magische Pulver hat, das einen dabei unterstützt. There are some people which say it's totally true, it's not the flux, it's the skill, it's totally true. Ja, das stimmt vollkommen, sagen einige Leute dazu. Es ist nicht das Flussmittel, sondern die Fähigkeit oder das Fähigkeitenlevel, das eigene. Von Paul Voss, so from Paul Voss. Beautiful and clear presentation, very interesting. I think the best tip is practice call. Thanks a lot. Practice, practice, practice. Paul Voss hat als Kommentar dazu eine wunderbare, klare Präsentation, sehr interessant. Ich denke, der wichtigste Tipp ist, dass man die ganzen Sachen im kalten Zustand ausprobiert. Vielen Dank. Üben, üben, üben. There's another question from Job van der Seyden. Is welding without flux with the induction heater possible? Ist Feuerverschweißen ohne Flussmittel mit dem Induktionsofen möglich?
If you think about the purpose of flux, once you get past that it helps your confidence, it's about that iron oxide. So if it's heating up really fast and you're not getting as much scale and you can get it to the anvil before you've got that oxidation, yeah, you can weld without flux. I went ahead and fluxed it because it was an experiment and I wanted to be consistent, but I would try that. I'm all for experiments. The more experiments, the more you learn. And I would say it is possible with the induction heater. I know it's possible with a coal forge because I have welded without flux. I don't do that as a rule because I do want that extra time. But short answer, yes.
Die kurze Antwort ist, ja, es ist möglich. Die Sache ist eben die, dass man möchte, dass die Oxidschicht möglichst weg ist, also dass man möglichst wenig Oxidzunder dazwischen hat, wenn man die Verschweißung durchführt, und dass, wenn du in einer Induktionsesse das mit dem Erwärmen sehr schnell funktioniert, dann ist das wunderbar und dann hat man wahrscheinlich relativ wenig Oxidation oder Zunder, und deswegen, ja, es ist möglich. Ich kann aus eigener Erfahrung zufügen, es ist wunderbar möglich, aber es ist erheblich einfacher mit Flussmittel. So, und das hat Victoria zum Schluss dann auch noch gesagt. Ja, es ist vollkommen möglich. Sie hat das auch schon ein paar Mal gemacht mit dem Induktion, mit dem Kohlenfeuer und so. ohne Flussmittel. Aber es ist halt einfach erheblich entspannter, wenn man die extra Zeit vom Flussmittel hat. The only thing you didn't say is, I have been trying this, like me, and it is totally possible without a flux, but it is easier with.
And I see Mariano said here, I think the time the piece remains in the heat is more important so that the entire piece takes the correct temperature, especially when the piece is very thick. And that is so right. You want it in your fire, you want it turning, you want a nice even heat, and you want to make sure that that's heated all the way through the middle. So the bigger the heat, and again, I'm using mostly a coal forge. I start in the cold part, I warm my piece up, I get it into the hotter, till now I'm getting it to welding temperature, but I have confidence that it's heated all the way through. So that to what Mario is saying there.
Mariano hat dazu angemerkt, dass er der Überzeugung ist, dass die Zeit, die das Stück, also das Eisen im Feuer ist, erheblich entscheidender ist, weil es dann eben die korrekte Temperatur bekommt, die es zum Feuerverschweißen braucht und durch erhitzt ist. Das hat Victoria bestätigt und dazu angemerkt, dass sie normalerweise das so macht, dass sie an einer kühleren Stelle im Feuer beginnt und dann zu einer wärmeren Stelle das Stück bewegt, sobald sie sicher ist, dass das Stück durch gewärmt ist, damit man gleichmäßig auf die zum Feuerverschweißen benötigte Temperatur kommt. Michael Poos hat gefragt, hat jemand schon mal das Verschweißen von normalen Baustellen, also S253JR, ausgeführt? Diese Stähle sind sicher nicht so schweißbar. So has someone already tried to use this normal structural steel? And there's the European number. I don't know what this translates to in America.
Aber Zahlendreher, das ist der S235JR, also der normale Baustahl, wie man früher sagte, ST37.
Hat jemand schon mal Erfahrung damit gemacht? So, has anyone used this normal structural steel? I believe that's mild steel.
It's close to 0.25% of carbon, something like that. Have a little more carbon than mild steel.
So has anyone experiences on that?
Es hieß sonst immer, er wäre bedingt schweißbar, wenn er beim ersten Versuch nicht packt. Dann wird er bei den nächsten Versuchen nicht mehr funktionieren. Das heißt, anscheinend soll wohl der erste wichtig sein, dass das dann wirklich gut funktioniert. Ansonsten hat man Pech. Also bringt das nicht mit. Wenn du so ein altes Schweißeisen nimmst oder einen historischen Stahl, dann ist das wieder eine ganz andere Nummer, ne? Wobei du da auch nie genau weißt, was du jetzt hast. Aber es ist aufgrund der Herstellung, wenn du so einen Pullstahl hast, ist der ja auf jeden Fall immer wesentlich besser zu schweißen als dieser Wald- und Wiesenbaustahl, den wir so immer benutzen. Ne?
So Michael said that he has been hearing that this certain structural steel is if it sticks the first time, you can successfully weld it, but otherwise it's not. And he said it's so different to this wrought iron that he has been hearing that it doesn't weld so well. And I can say it welds totally well if one brings it to the right temperature. I have been trying this in the induction forge lately fairly often. And it works like a charm. I don't have anything else. Ja, ich kann aus meiner Erfahrung sagen, wir haben den S-Baustahl, von dem du gesprochen hast, um da jetzt keinen Zahlendreher reinzubringen. Und der verschweißt sich zumindest im Induktionsofen wunderbar. Mehrfach ohne Probleme ausgeführt in der letzten Zeit. Und ich denke, das ist einfach eine Temperatursache. Und wir haben damit auch immer in der Schule verschweißt. So, also es scheint eigentlich kein Problem zu sein. Oder ja, so ein Mysterium, so ein Mythos. So, and I added, we have also been using the same steel in school, and it has been no problem. And it's probably a myth that it's not working if one doesn't get it right the first time. So there have been a lot of more questions, with a lot of them being thank you. Job van der Zijde says, in my experience, a big roomy fire makes it easier to heat up easy because the oxygen-free center is bigger. Job van der Zijde sagt dazu, in meiner Erfahrung ist ein großes raumfüllendes Feuer einfacher, um das Material auf Temperatur zu bekommen, weil das Zentrum freier von weniger Sauerstoff enthält.
Well, and you want to think about it this way too. If you want to get your metal yellow, you better have some yellow fire, or it's not going to get that hot. It's all, you know, your metal's only going to get as hot as your fire. And if you start with a coal fire and you put your metal in there and you wait for it all to come up to temperature, you're just kind of asking for scale and material loss. So, I mean, get the fire big, and I like the word roomy. That's a nice word to use, big roomy fire. I want a lot of yellow in there before I stick my piece in. And then it's where I put it that becomes important. Totally agree.
Victoria hat dazu gesagt, dass ja, das Feuer muss natürlich, ist, wenn man den Stahl auf gelbe Temperatur bringen möchte, dann benötigt man natürlich auch ein gelbes Feuer, weil der Stahl nur so warm wird, wie das Feuer ist. Und dementsprechend ist ein großes raumfüllendes Feuer ganz praktisch dafür, weil man dann auch mehr Temperatur an den Stahl bringen kann. Man muss dann eben gucken, an welcher Stelle man das platziert.
Well, and I want to thank everyone for their kind words, and it's my honor to be here. This is a great group, and I really love what you're doing here.